Okay, this is lesson 27, section 5.3, evaluating trigonometric functions, part 2. And here we're going to be taking a look at more right triangles. We've already looked at this. This is kind of a review for us. And here's our table. And I mentioned that you could, as long as you knew the special triangles for 60, 30, 90, 45, 45, 90, that would be easier than using the table. Okay, here we have this triangle here. And we have, here labeled, we have one angle is 45 degrees. In one triangle, so we actually have like two triangles adjacent to each other, or juxtaposed to each other. And then we also have 60, 90, 40, 60. So this would be basically 7 opposite that. So let's take a look at how this problem would be worked out. All right, so we have one triangle, and we had 60, and then 7, and C. And then we had another triangle. It kind of came across like this. And that was 45. Well, one way to look at this is look at, one triangle at a time. Okay, what we want to do here is we want to go ahead and find the exact value of each part. Okay, so those are the parts that were given, but we want to find side C, we want to find side A, side N, and R. Okay, well, here we can find side C by using, we can use tangent. Since we have opposite and adjacent, we can use tangent of 60 degrees equals to, and tangent we know is opposite over adjacent, so that would be 7 over C. All right, so tangent, looking at our special triangles, tangent at 60 degrees, here's 60, we said tangent is opposite over adjacent, that's square root 3. All right, so tangent at 60 degrees is the square root of 3, equals to 7 over C. All right, so you have, if you're given one of the special angles, either 30, 60, 90, or 45, 45, 90, you can use these special values. Well, if we multiply C to both sides, right, we get C, we get square root of 3 times C equals to 7, and then we divide by the square root of 3, we get C equals to 7 square root 3 over 3. Okay. Now, we could also, now let's look at side A. So here we found side C. Now we want to find side A. Okay, so which trig ratio can we use? Sine, cosine, or tangent? Well, you want to look at, you have an opposite side, and what else do you have? What is A in this triangle? Travis? The hypotenuse. So which trig ratio could you use opposite over hypotenuse? Sine, right. So this would be sine 60 degrees equals to opposite is 7 over hypotenuse is A. All right, well, sine, if we look back at our special triangle, right, sine for 60 degrees is what? Sydney? Well, we're looking at 60. Right. Square root of 3 over 2. Good, because it's sine. All right. So this would be the square root of 3 over 2 equals to 7 over A. So if we multiplied A to both sides, okay, and we've got A, we've got square root of 3 over 2 times A equals to 7. Well, if we multiplied 2 to both sides, right, and divide by the square root of 3, or we just apply the reciprocal, we get A equals to 14, and then what follows after that? What else do we have? Dylan? 14 square root of 3 over 3. Good. 14 square root of 3 over 3. Okay, so we have here 14 square root of 3 over 3 for side A. So you have to find this side here before you can come up with the other values. All right? So here we can use, here's angle 45 degrees. Which ratio can we use for that? Sine, cosine, or tangent? Let's say we're trying to find side N. Well, what is this? Is it opposite, adjacent, or the hypotenuse in relation to 45 degrees? Opposite, right? So if this is opposite, what's N in relation to 45 degrees? Adjacent. So what can we use as far as opposite and adjacent sides? Sine, cosine, or tangent? Tangent, right? Since tangent for 45 degrees is opposite over adjacent is what? We want to find side N. Okay, we've got tangent of 45 degrees equals to 14 square root 3 over 3, and that's over N. Well, tangent of 45 degrees, opposite over adjacent, right? What would tangent of 45 degrees be? Opposite over adjacent. Travis? 1, right. So we can say tangent 45 degrees is 1 equals to 14 square root 3 over 3 over n. Now what do we do? Dylan? Right. Multiply both sides times n. Well, then this just becomes n equals 214 square root 3 over 3. Okay? So this is 14 square root 3 over 3. All right, now all we have to do now is find side r. Well, whether you use sine or cosine, really that doesn't matter because it's the same, right? So let's use cosine. We're going to find side r. So here we have cosine of 45 degrees equals to adjacent over hypotenuse, right? So which side is, well, whether it's adjacent or opposite, it's still going to be 14 square root 3 over 3, right? Over r. Well, what's the cosine of 45 degrees? Sydney?
The same thing.
Well, I mean, we have to go back to our special triangle. We're looking for, we're trying to put in a value in for here for cosine of 45. So you have to go back to your special triangles, right? Cosine of 45 degrees? 1 over square root of 2, which rationalizes to square root of 2 over 2, right. So this would be square root of 2 over 2 is equal to 14 square root 3 over 3 over r. So we multiply both sides times r, right? And we get square root of 2 over 2 r equals to 14 square root 3 over 3. Now what? Dylan? Well, we're trying to isolate r. Yeah, multiply 2, right? And so basically we can just apply the reciprocal, right? So actually, let's just do that. Let's just multiply the 2 first. So we multiply 2 to both sides, and we get square root of 2 times r equals to 28 square root of 3 over 3. All right, now we're going to divide by square root of 2. Well, there's a 3 there, so you're going to you're just multiplying 3 times the square root of 2. Okay, it's like it's the same thing as if you apply the reciprocal to both sides. Okay, so that just becomes 28 square root of 3 over 3 square root of 2. But we have to rationalize that, right? So we have to multiply the square root of 2 over square root of 2. So we get r equals to 28 square root of what? Harley? 6 over, well, this is going to be 3 times the square root of 4, right? Which is going to become, that's right. That'll just become 2. And so you get 28 square root of 6 over 6. But we can simplify that, right? Because 2 can go into both. So actually, we could have done it here, too. Could have canceled 2 into 28 and got 14. And so this would be 14 square root of 6 over 3. Okay? Questions with that? Okay. Okay, reference angles. Here we have our x and our y coordinate plane. If we have our angle theta going on around, we have a reference angle is an angle that is an acute angle, and always in reference to the x-axis. And we call that theta prime. There's that little mark there. That's so here we're in the third quadrant. So again, you're going to be taking the reference angle from 180, right, minus whatever your angle is, and that's what your reference angle is going to be. Well, why do we do that? Well, if you can get a special angle from that, then you can find the values for more exact values for within your special triangles that you can use. So that can be useful for us. A common error is that students may use the y-axis instead of the x. You're always going to reference in terms of the x-axis, always. Okay, no matter whether you're in, the negative side or the positive side. Okay, so we want to find the reference angle of 218 degrees. All right, so, well, you always want to look at this as 180 degrees right here. So basically, it's just 218 minus 180 is 38 degrees. Okay, so our reference angle for 218 rather, is 38 degrees. Okay, find the reference angle for an angle of 1387 degrees. Well, we know that, first of all, one complete revolution is 360, right? So if we go 2 times around, it's 270, or 720 rather. 3 times around would be 1080. So 1387 minus 1080, and we get 307 degrees. Well, the 307 degrees minus 360 gives us a reference angle of 53 degrees. Okay, so let's look at this. Oh, that's right, I can't do that. Excuse me. So let's look at this again. You've got here one time around 360, second time around 720, third time around 1080. So basically you're taking the 1387 minus the 1080, and we get 307. Okay, well, here's 307. If this is 90, 180, 270, right? This is going to be 307 here. So we want to find the reference angle to that. So we take 360 minus 307. Okay, and that's where we get the 53 degrees. All right, questions with that? All right, so the first quadrant, whatever angle you have, that's your reference angle as well. Second and third quadrants, you're either going to be subtracting that angle from 180 or that 180 from that angle. And then quadrant 4, you're just subtracting 360. Okay, So find the values of the 6 trigonometric functions for 210. So here we draw it out. Here's 210. We subtract 210 from 180 to get our reference angle, and we see that it's 30 degrees. Well, if we were to look at our special triangle, right, 60, 30, 90, here's 1, 2, square root 3. We want to find sine, cosine, tangent. But you have to remember that we're in quadrant 3. So y is going to be negative. Cosine is going to be negative, and sine is going to be negative. So this is going to be negative square root 3 over 2. And a negative 1/2. Tangent's going to be positive square root of 3. Okay? And then for cosecant, secant, and tangent, you just apply the reciprocal, right? So this would be negative 2 over the square root of 3, so that'd be 2 square root 3 over 3. And secant is going to be negative 2. Tangent is going to be 1 over the square root of 3, so that'd be the square root of 3 over 3. Okay? Questions with that? We'll do some problems with that. So here it is. It's all laid out. Okay? And you could even do it on here, since you have your special triangle, right? 60, 30, 90, 1, 2, square root 3. You could put 30 opposite is 1, so that'd be negative 1. Hypotenuse would be 2, and this would be negative square root 3. You could do it that way too. Okay? Okay. Finding the trigonometric function values for any non-quadrantal quadrantal angle. If theta is greater than 360, or if theta is less than 0, find a coterminal angle. And you're just going to add or subtract however many times you need to get 360. Find the reference angle, and then find the trig functions from that. Biggest thing is to find the correct signs. Okay, so for a cosine of negative 240, we're going to negative goes in a clockwise direction. So you would take 180 minus 240. Your reference angles are always positive. Notice that's positive. So 120, you get they added 360, but you could also so then from there they took 180 minus 120. But you could have also used 180 minus 240 and you could have gotten 60 that way too. Just remember that your reference angles are always positive. So then you've got a negative, they get into a negative cosine 60, which we haven't done, and at this point it's easier just to draw out a triangle. Here's 60 degrees, and then just do your from there you can do your 1, 2, square root 3. So this would be 1, 2, square root 3 like that. Or no, that's the other way. Square root 3. This is negative, positive. So sine, for cosine, that would be negative 1/2. And there it is. Okay. Let's take a look at some other problems. And let's say that we have find the reference angle for negative 135 degrees. First, draw it out. So it helps if you write out 180, here's 90, 270, 360. Okay? So which way, first of all, which way are we going for 135? Clockwise or counterclockwise? Travis? Clockwise, right. So this would be like negative 90, negative 80, negative 270. So this actually puts us in quadrant. Do you go before or after 180? Since it's a negative 135, that actually puts us in which quadrant? Sydney? Quadrant 3, right. Well, this is theta, but we want the reference angle. Okay, so what do we do? Harley? We want this angle here. So we're always going to have this in reference to what? The x-axis. Good. So that means we have to subtract 135 from what? Well, which one's closer? 180. 180 is closer, right? So we subtracted from 180. So it's 180, right, minus 135, right? And so that would be 45 degrees. Okay? So we have here 45. All right? Well, if we look at our special angles, right, for 45 degrees, we've got 1, 1, square root 2. So that would be the same thing as if we made this negative 1 and 1, but they're both negative, right? Because we're in quadrant 3, square root 2. The hypotenuse is always what sign? Dylan?
Square root 2.
Yeah, it's square root 2, but the hypotenuse is always what sign? Positive or negative? Hypotenuse is always positive. The hypotenuse is always positive. Hypotenuse is always, always positive. All right? All right, good. So now, coming up, now that we know SOHCAHTOA, right? Come up with sine, cosine, 45 tangent, and its reciprocal identities. Okay? Go ahead and do the rest of that. Okay. Travis, what would be the sine of 45 degrees?
Negative square root 2 over 2.
Good. Negative square root 2 over 2. And what about its reciprocal?
Negative square root 2.
Negative square root of 2. And that would be what? Cosecant. Good. Cosecant of 45 is negative square root 2. Very good. Cosine? Sydney? Negative square root of 2 over 2, so that's reciprocal secant. Good. Good. Negative square root of 2. And how about tangent? Harley? 1. Good. And how about its reciprocal identity? Good. Cotangent? Also 1. Very good. Okay? Questions with that? Okay, let's try one more. And let's say that we have find exact values for all 6 trigonometric functions for let me just check something here real quick. Okay, actually, yeah, for 750 degrees. All right, well, I'll get you guys started with this. Well, we know 1 time around is 360, right? What's 2 times around? Well, that's 360 times 2, right? Well, that would be what? Well, 2 times 36 is 72. So 2 times 360 would be 720. Well, can we subtract 750 minus 720? We can, right? What do we get for a reference angle? Well, what's 750 minus 720? Harley? 30, right. So that actually puts us in which quadrant? Came out crooked. That actually brought us out to first quadrant, right? So using our 60, 30, 90, right triangle, come up with the values, use the SOHCAHTOA, come up with your values, and write out your 6 trigonometric functions. All right, go ahead and do that. Oh, this is 30. Okay. Dylan, what would be the sine for 30 degrees? Well, remember now, this is 60, 30, 90, so this would be 1, 2 square root 3. So for 30, basically if you took 30 degrees like that, put that on the bottom, 60 on the top, all you're doing with these two sides is you just flip them. So that puts the square root 3, 1, square root 2, like that. Okay, so that might be an easier way for you to do that. So that makes this square root of 3 for the adjacent, 1 is the opposite. 1/2, right. And then cosecant, that would be 2. All right, how about cosine? Harley?
Square root 3 over 2.
Good. Square root of 3 over 2. And secant?
2 over square root of 3.
2 over square root of 3, but you got to rationalize that, right? So that makes it what?
2 square root of 3 over 3.
Good. 2 square root of 3 over 3. Okay, and then tangent. How about that? Travis?
Square root of 3 over 3.
Good. Square root of 3 over 3. And cotangent?
Square root of 3.
Square root of 3. Good. Okay, questions with that? All right, does anybody need to see another one worked out like that? Okay. All right, well that